folks. Welcome to another edition of Beyond the IT Headlines. Today, we're going to be talking about synthetic data. More specifically, how and what can we expect from synthetic data? Specifically here, I am absolutely pleased to announce that our guest for today is Par Boats. Par has been with us here for many years, but Par's experience really transcends well beyond the walls of Pure Storage. Originally starting at Sun Microsystems with some time at Symantec, and then most recently at Ghost Locomotion, helping to really drive the next wave of autonomous driving. Par's now back with us at Pure Storage, but he brings with it a tremendous amount of experience, real-world experience, as it comes to using data to create AI solutions. Par, welcome to the show.
Hey, thank you so much. And yeah, what an accurate description of my background.
Yeah, it's, maybe tell us, Par, as we jump in before we get into our question and our topic for today, if you were to look at the last, 30 years in this industry, what really stands out at you? I mean, is there a couple of key things that really sort of come across your mind that really have been the hallmark of the last 30 years?
I think three events stands out to me. 90s client server came big. I mean, it didn't really exist before the 90s, or maybe it did in some research, but that undid the whole mainframe mini computer. That's what brought the whole Linux and Unix generation. It started out with big honking iron and it became smaller, more distributed systems and N-tier architectures. That started all in the 90s, and it was a delight to be part of that and the rise of Sun. And then 2000s, let's say, particularly mid to late 2000s, the rise of the cloud was quite exciting to see the change of the security paradigm, the change of the interfaces, the change of thinking about hardware and software together, and instead thinking about the service. I think that was just fascinating and quite enjoyable. And I worked a little bit on that, but like I can't say I was deeply involved in that. I was more in the enterprise tech. And then I'd argue 2017, the Transformer paper and what that did for the world in terms of AI, and kind of my eyes truly opened up. In 2020, I started working on AI for real and building neural networks, and it really changed the way I thought about computers and where computers going to go next. And these three events are quite something for me.
So let's talk about that for a moment. So your experience really transcends the deep guts of AI. You talked about 2020.
Yeah.
Obviously, we're now in 2025.
Yeah.
When you look at your direct experience in this space, specifically at Ghost, where you built a bunch of these systems and training models and inference models, and I would say as real-time and autonomous as one could imagine, what were some of the key learnings you took away from that experience?
Oh gosh. So, so we did some things really right at Ghost. We also did some things perhaps not so right. And uh, in 20, like before 2020, it's not like a clear architecture for in-car driving. It's becoming a pretty clear winning architecture. I argue it's probably anchored in the East in the Chinese car manufacturers, but it's starting to kind of move over to the West. In 2020, every initiative every car had was its own little unicorn. There was no real resemblance between startup to startup, but it started to become they started to see a real clear architecture. The second thing, and this kind of goes a little bit to the software side of the house, is there's no real super obvious training architecture. Like every company had their own ideas on how you're going to make your developers productive, and we're starting to see much more clarity on like what the infrastructure looks like for training and building and running AI, and what the common patterns are, and that saves a bunch of times. I argue it's not done yet. We're going to go through a few more iterations, but I think certainly those who worked on large scale AI, and I think the self-driving cars certainly worked on some of the larger scale AIs. I don't want to take anything away from OpenAI and the likes, but outside of that, the self-driving car companies drove a lot of learnings on how to build scalable training data sets. But the bigger thing for me was we were so naive in the early days. We thought, we can sample, we drive around the world with a car, sample the world, and then Then whatever we didn't have, the events we didn't have, we can supplement that with basically, I mean, we're reading about their camera sensors, largely camera sensors, radar sensors, lidar sensors, some form of sensors. And what you're looking for is like unexpected long-tailed events, things that a car needs to deal with that doesn't happen every day. It's unfeasible to drive around forever trying to find these events. You try to add in some capabilities to simulate this, or some mechanism in your software to handle it correctly. And we were on this idea that we could simulate everything. We could build synthetic data that generated everything that we couldn't see by ourselves. And boy, were we wrong. It just turned out that didn't work out that well. The AI kind of, the models kind of learned what was synthetic, and it degenerated, and it didn't work out a bit. We could do a little bit of synthetic data. We couldn't do a ton of it. That was like a big sort of, oh, we just wasted a year or two of our time with this. And we had to rethink our approach. And we come up with some new approaches, but it was some good hard learnings there.
So, I mean, that provides a great segue to today's episode, which really touches on synthetic data. And just to catch the audience up, the models that are out there, you mentioned OpenAI, we could talk Anthropic, we could talk Claude, we could talk Llama. We've essentially trained off of what's available on the open internet. The open corpus of what's available to all has essentially already been digested, already
Yeah,
been eaten.
yeah,
And although we are creating data at a very, very high rate, the reality is that new human generated data is becoming scarce. There's
yeah,
not as much of it
sure.
as there was in the corpus, and it's legally restricted. A lot of that data is not public corpus. I mean, you use the autonomous driving example as how do I kind of create the unpredictable to train the model. But the easy fix here, in at least the academic side, was synthetic data. And I think I really want to unpack that today because there's been a lot of mud thrown at synthetic data. It can't work. We can't use it. It's got all sorts of. But I want to give the audience here kind of a balanced view because this isn't something new, right? In fact, if we look at some of the studies done by Carnegie Mellon and Microsoft, we can see that synthetic data is actually crucial for filling in a lot of the gaps that are
Yeah,
there,
yeah,
helping to scale models. Yes, there are challenges, and we'll get into some of those, but this is not new. We've been
yeah,
using synthetic data for facial
yeah,
recognition, for self driving, for healthcare, right?
yeah,
Anonymizing patients, trying to build pathology, as well as finance, building hedge models, high frequency trading models, robo models. But the big difference today is that tools have emerged that make it easier than ever to create and expand the data sets. And we have more and more people outside of research who are actually making decisions on what data to include and not include within their AI models. So I want to just get your high level take here, Par. I mean, you've
yeah,
shipped real systems. Where
yeah.
did synthetic help? And what did you learn around where did it kind of fall short of expectations?
I mean, it worked really well for like things that were rare, or I make this simple analogy, like traffic lights. It's really easy to generate data with recordings of traffic lights are red. Stop in your way to the traffic lights. It's really easy to generate data around traffic lights that are green because you drive through traffic lights. It's really hard to generate data. It's not that hard, but it's a little bit harder to generate data for traffic lights that are yellow because that happens much less often. And the chance of you driving through and recording at the very moment when they turn yellow is less frequent. So you could argue that instead of trying to figure out how to create scenes where lots of messy cars and things and people walking in the intersections and so forth, it's easy to, let's just fill this in and let's just paint that red and let's just blacken out the paint that yellow and blacken out the other signals, and so you can try some of these approaches, and for some amount it actually probably will work. What we found is if you did mostly that, you mostly did the synthetic data and didn't have any real data in image, the real world differed in subtle but small ways. But it had this cascading effect on the neural network, where the neural network really got it wrong. It
Hmm.
learned what was synthetic and it didn't see what was real. And then when you exposed it to the real, it didn't quite see it, or it didn't predict the right thing. And so what we found is, yeah, for some small sets of data, actually was fantastic. For really large sets of data, it wasn't that great. And I don't know if you can do a rule of thumb or not, but what we found, at least a project that I was working on at the time, is that Once the synthetic data set become much more than about, say, about 10% of the data corpus, the system kind of picked up what was synthetic and kind of we talk about model collapse, but it kind of degenerated into model collapse. I don't know if
Mm.
that's true for every type of model and every type of problem, but that was absolutely our experience. So we found it absolutely had its place. But certainly when you're prototyping, when you're developing, when you work on something in the early days, yeah, so data is great. You can very rapidly create a small data set that represents something bigger that you then can go and kind of find. And you don't have to wait to find it in order to start developing. But yeah, that was our real experiences.
Yeah, I love the analogy and I love the
Uh,
use case of autonomous driving
uh,
because you
uh,
think about the predictability when
uh,
I mean we take it for granted as drivers, but we're driving down the street, anything can
uh.
happen. A
And
kid could,
a
fall
simple
down the
and
street.
that's just on the environment you're in. But you have simple stuff like sensors, like sensor get a half pixel of yellow and a half pixel of some other color. If you generate a synthetic, it's also going to be somewhat perfect pixels. So the
Mhm.
AI learns to look for like perfect pixels and then see half pixels. And so when you see an image that has yellow but it's half pixels in it, they're like, no, that doesn't look right. And we actually studied that quite a bit and then realized that noise and shakiness and you have to introduce noise into an environment for that to make the AI very, very robust. And we do synthetic approaches to noise generation as well. But noise is very, very hard to generate synthetically without also creating patterns in it. And that becomes this so really big circular problem that isn't super easy to solve.
Well, it's funny to hear you say that because if I just move to a use case like healthcare,
Yeah,
right? I mean, I could generate all sorts of synthetic pathology, but the
yeah,
fact is, humans don't always tell us or know what's
yeah,
wrong. And what they
yeah,
tell us
yeah,
actually may have no connection
yeah,
or may completely not be true. And
yeah,
that's not generally, factored into synthetic data. I like what you said. Synthetic data is perfect. I loved your
yeah,
example of the traffic light. The
yeah,
pixels are 100% red.
yeah, yeah,
Depending on the time of day, the refraction off a building,
yeah,
what other factors are in play, it's not going
yeah,
to be perfect. And so if
yeah.
you train the market for perfect without that imperfection, then when you take it into the real world where those imperfections exist, the model collapses.
I'll give you a really cute example. This is so obvious when I tell you. But like lane markers, you lay out lane markers. Think about how is lane markers laid out in the real world. You have a car or a truck really with some paint system and a brush that comes off the side that drives along the road and drops down the arm every so often to lay out the lane marker. That means that when the road is curving, the lane marker ever so slightly curves. If you look at a lane marker, have you ever considered a lane marker curves on the highway? I mean, I haven't. It looks kind of straight to me. So when you paint it in your tool, let's say Photoshop. I mean, we didn't really use Photoshop, but let's say you use a tool to paint in some lane markers where the road had worn it out and you want to train that data. And you lay in straight lane markers. And the neural network only saw straight lane markers. And then went to the real world and tried to drive. But the real world contains slightly curved lane markers and they didn't quite fit. And the car didn't realize that that's a lane. That's a really, that's a true example. That was like one of our most naive early models we built had that problem.
It's a great example,
Yeah.
and I want to kind of get to.
It's errors. The real world is noisy, it's messy, it behaves certain ways. And once you understand it fully, once you can explain the world completely, then it's easy to generate synthetic data. It's actually hard for us to do.
Yeah, it's interesting. I mean, I've driven sometimes behind some of those trucks that are painting the lines, and let's just say there's not always perfection in the
It's
application of those
definitely not.
lines. Sometimes a line gets missed. I've even had my car jolt me out of a
Yeah,
lane, thinking the lane ended, but it actually didn't. It was just
yeah,
a lane marker that was not properly put on the road. So
yeah,
there's a lot of thoughts here,
yeah,
but the fact is, Par, we're moving at kind of, you know, um, we're moving at rocket speed in AI.
yeah.
And ultimately, if
Amazing.
we have exhausted the corpus of what's available,
Yeah,
then we are going to get to synthetic. And it's not inherently bad,
yeah,
but we have to be really conscious of the use case. So I
yeah.
want to spend some time just looking at
But
if you look at simulations and
yeah,
you look at generated text
yeah,
and you look at the augmentation of text,
yeah,
give me some of your thoughts. I mean, where, if you were looking at this market and thinking where we're headed,
yeah.
what are some of the bright lights that stand ahead, and what are some of the things that really jump out that we got to be careful about?
Our knowledge about, I mean, our knowledge of the problem is expanding, and our knowledge about about how to describe the world is increasing rapidly, and our knowledge about how to describe data is increasing rapidly as we're spending time on these types of problems. And as we learn more, as we get better at it, actually, I'm somewhat certain that when we come up with an approach, it's going to make it easier. It's going to make it easier, make it better. I don't think it's solved, but I'm somewhat optimistic that it will be. I think it for constrained problem sets, I think it's fairly well understood. I mean, you can navigate warehouses pretty well with synthetic data. I don't think you really need to go to the real world for that. Because warehouses are confined, we control the whole environments. The real world and text and language is not well understood, and language evolves over time. Language is an encoding of information. I mean, you and I have a low bandwidth connection. We can only do so many bits per second. So when we convey more complex information, we have to create a new word to represent whatever information we're conveying. So language evolves consistently, continuously, and synthetic data that's representing that language has to evolve with it, and intent and meaning and thought and behind it has to evolve with it. But I think we're having some really smart people thinking about this, and actually, I think it's becoming better and better. I don't think you could make the shortcut in the early days, but we're only 5 years in, maybe basically only 3 years in to think about this long and hard. And I actually think this is becoming easier and better as time progresses. But I don't think it's solved. I do think it's enough of a problem, and it's valuable enough problem that people are really thinking long and hard about it.
Well, so
So,
to that note, around thinking
yeah,
long and hard about it,
yeah,
I've said in previous episodes that ultimately, a lot of the human generated content is a problem. And
yeah,
along with synthetic data could very much create model collapse. And
yeah,
we're likely to get back to raw content, raw
yeah,
footage,
yeah,
high
yeah,
entropy interactions.
yeah, for sure.
Um, what's your feel about this? I mean, how's this really going to change the way that we and companies capture data, the way that they feed data into their models? How
You,
do you
you,
see this moving?
but you brought in a dimension we haven't really talked about before, which was companies. So I argue that most of the world's data, uh, which is trained on the internet data, is public data. But private data, companies also have data, lots of data. This data is represent things that has semantics to that company, but maybe not to other companies. If you look inside of our company, we have ways of expressing what we do and the processes we have and how we operate things that are somewhat unique to us. And you go to someone else who uses the exact same language, that might mean something different. That style of data, I argue, is largely not been trained in on. And so I think there's a whole new body of data waits to be trained on. We can't just give it up and make it available into the public domain and make anyone train that data. But there's a new way of training for this data, I believe, that is going to make it secure. It means it's confidential to you, to the business that has the data, but yet it's going to expand the knowledge of these systems with that type of data. And we don't yet quite fully know exactly how to do that. We went down the RAG path, the retrieval augmented generation path for some of it. That doesn't appear to be like the ideal path either. So, but I'm pretty sure we're going to find an approach to this, or currently agentic is kind of a new way to think about it. But I think we're going to find a way through this that's going to make it easy to interact with data and learn from data that isn't public, that needs to be confidential, but yet needs to add to knowledge. And where we have to understand the shape and the structure of that data. Exactly
Okay,
how,
so
I don't really know.
look, you're in the engineering side. You're building
Yeah,
these solutions.
yep,
So if
yep,
you were advising architects and engineers out there that are thinking
yep.
about how to grow and build their next generation of model,
Yeah.
what advice do you give them? What's the 3 to 5 things they got to do?
Super great question. So number one, you got to get your data management done right. You can't just, dump data into a location and let's call it your if you go back to Hadoop era, and the Hadoop era premise was basically dump all your data into a bucket, into this big data table, and you can kind of do something with it. I don't think that works at all. I think that's just a bunch of mess. What you need to have is a pretty solid data management system, allows you to create like lineage and tracing where data originated from, of how data was used, of what data is junk and what data is good. And so you can scrub it, you can interact with it, you can correlate it, you can enrich it, and you can prep it for AI. And then when you train with it, you want to have the ability to say that, okay, so this was trained with that data, this version. Because remember, this data continuously evolves too, as does models. So as these evolve, you want to have that system in place that allows you to train and match it to the data corpus and go forward. The second thing I would do, this is super duper hard, but like you're gonna understand what data you have is. How do you know it's complete? How do you know it's correct? How do you know it? How do you know you have enough data? How do you know the right distribution? We spent, particularly in the self-driving car, and I think everyone in that industry does it. We spend a tremendous amount of time to ensure that we have the correct data corpus, that we have the right distribution, that we have the right amount of certain types of data. Because if we don't, then we train the network with biases. And if you train it with biases, then the network is going to predict wrong. And if you predict wrong, then you're going to hurt someone. We don't want to do that. So, and that's inherent in every network you have. You want to make sure you don't have biases in the network. So that fundamentally makes it a data management problem. And I think people underestimate how much you need to pay attention to the data in order to make the network work well.
Yeah, it's funny to hear you see this. I took a couple things away from what you said. So the first was you talked a lot about data provenance. You talked about a
Yeah,
lot about data
yeah,
um, lineology.
lineage.
So really, what's organic? What's synthetic? Where did I
Yeah,
get it from? Where did
yeah,
it come from?
yeah,
And if my model starts to collapse, can I
yeah,
actually isolate what
yeah,
data set or what
yeah,
data
yeah,
sets were the cause of that
yeah,
collapse?
yeah,
I also, heard you talk a lot about um, contamination, right? Really
yeah,
being able to control what's actually happening and even make tests that say, if I took a small subset of this data, what would
yeah,
happen to my model? Which way
yeah,
does the model deviate?
yeah,
I also talked, you talked a lot about context, and I'm very passionate about this. The
yeah,
human has to stay in the mix,
yeah,
right? At the end of the day, the human knows whether or not the model actually makes sense. Sometimes the model doesn't know whether the model makes sense. The human has to say, yeah, that actually aligns with the randomness of the world and the randomness
yeah,
of what we do. Um, but ultimately, when it comes to the next generation, and I'm going to put you kind of on the spot here,
yeah.
um, is the next kind of iteration of what we're building, is it more aligned to the licensing and the buyout of private data sets, call it research or academic libraries? Or is it really the build out of better quality synthetic data sets? I mean, which one's going to win out here? And where would you put your bet?
Oh man, that's a diff. I mean, can you? I don't know if I can choose between those two because I think both are kind of equal important. Like you gotta have really high quality real data sets, and I mean, you see this over and over. I mean, DeepSeek published the mechanism by which they found data and but really selected the subsets of that data in order for them to train on. And that was like super, super nice for them to do. I mean, we used the word distillation and so forth. But it's essentially, how do I take a data set and how do I make it higher quality? And they had a pretty neat approach to think about that for math and things like that. And so that's the data set side. Then there's synthetic data set side of it. Also is going to matter. You can't quite avoid it either. So I mean, okay, yeah, these things like it's like picking between good and good. They're both good. Like I can't pick a winner. I mean, I do think you have to have. You could probably survive without synthetic data. I don't think you can survive at all without real data. I don't think you can. You have to have it. And you can certainly not survive without having the ability to have ways of testing it, whether it's human in the loop or whether there's a way for human to express things for to drive human knowledge through automation loop. I don't know. But like you cannot these three things are kind of hard to trade off from. But I would argue you're not going to find a winner between these three things. They're all going to win.
Well, I mean, I do think that it's, in very many cases, AI is not an or,
Yeah,
it's an and.
yeah,
But the reality is, I mean, today we really talked about the fact that Pandora's box is open. These models
yeah,
are being built. These
yeah,
models are evolving. We
yeah,
want them to get a better and better understanding of the real world, right? We talked about autonomous driving, we talked about data sets. The fact is, to do that, we need to feed them more than reflections. We need to feed them
yeah,
more than perceptions. We need to actually
yeah,
feed them reality
yeah.
because AI will not get smarter just studying its own homework. Any thoughts you want to leave our audience with before we close out here?
Well, um, I'll make an observation about AI and so the problem, I mean, you kind of hinted at it, like lots of AI is now used to generate data sets with. These data sets are now or used to generate outcomes with. These outcomes are now published on the internet as if it was a human who generated it. We've all seen, social media is full of things, and you look at it, now that actually wasn't written by a human. That was written by an AI, by a human prompted AI to do something because they didn't want to type it up. And we started to observe, I actually started to observe, particularly in social media, people becoming very in tune with like, this looks like something AI created versus this looks like something human created. Because, there's a certain tone, there's a certain tenor that sort of has some variations that human create because we're a little bit sloppy than machines sometimes. And there's a little bit of backlash. Oh, that looks like AI slop. That looks like nonsense. So we started to have a little bit of bias towards like, hey, we like things to have human touch or human involvement. The same thing I think is happening. These data sets cannot be used by AI to train itself on, because then you're going to end up that things that doesn't exist in reality doesn't reflect reality. So we're having this interesting moment in time when we're having enough output becoming public that is AI generated, and some of that becomes circular and used back into the training system. And I think we're going to go through this period of time where we're going to have to kind of work through that, and I think that's going to be kind of interesting to see what happens next, because this can create that sort of
Recursive. Yeah.
synthetic loop,
Mhm.
recursive, that leads to true model collapse where you just hallucinate about everything.
Yeah, it's interesting, right? I always think about the fact that our brains, right? I mean, the average human lives 70, 100 years, and so we don't evolve that quickly
Uh,
because our life cycle is so long. Ultimately, our brains are not that different than they were 100,000 or so, years ago in our deep ancestors. But AI is evolving and actually training in
exactly,
minutes, in hours.
correctly.
And so, very quickly, AI will build the capability to actually build content that is indiscernible to a human. It almost
Yeah,
feels, Par, that we're going to need AI to tell us what's AI.
yeah, probably.
And the it's an exciting world ahead of us. I'd like to thank you, Par, for attending the episode today. I'd like to thank our audience for attending. And for those of you who are listening out there, I want to make sure that you like and subscribe so you don't miss an episode. We publish these relatively often. And if you're looking for more data, tech, and IT news, please check out our new site, thedatawire.com. And we'll see you next time.